A rare visitor from deep space is currently flying through our solar system, and this one is mind-blowingly huge. 3IATLAS is barreling past at over 150,000 miles per hour and could stretch up to 12 miles across, making it the largest interstellar object ever detected. Unlike asteroids or comets born in our solar system, this cosmic wanderer originated from another star system entirely. But here's what has scientists both excited and concerned. 3IATLAS displays characteristics that don't match any natural object we've seen before. Could this massive visitor be something more than just space rock? A rare visitor from deep space. Deep in the cold emptiness between stars, objects drift for millions of years before occasionally entering our solar system as interstellar visitors. 3IATLAS represents only the third confirmed interstellar object ever detected, following the mysterious Oumuamua in 2017 and Comet 2 Borisov in 2019. What makes this discovery extraordinary isn't just its rarity, but its unprecedented size and unusual characteristics that have astronomers scrambling to understand its true nature. The object's hyperbolic trajectory proves it originated outside our solar system, traveling through interstellar space for potentially millions of years before entering our cosmic neighborhood. Larry Deneau, principal investigator of the ATLAS asteroid survey, initially thought the detection was equipment error due to the object's enormous size and unusual brightness patterns. Unlike typical asteroids that reflect sunlight predictably, 3IATLAS shows irregular brightness variations suggesting either a highly elongated shape or surface features unlike anything in our solar system. The discovery has triggered an international observational campaign involving dozens of telescopes worldwide as astronomers race to gather data before the object disappears back into the darkness of interstellar space. This visitor may hold secrets about planetary formation in distant star systems and possibly answer questions about the prevalence of life in the universe. The breaking discovery. Tuesday, July 1, 2025, marked a turning point in astronomy, when the automated ATLAS telescope system in Hawaii flagged an unusual moving object in its vast database of sky observations. Robert Warwick, the same astronomer who discovered Oumuamua, was monitoring the system when the computer algorithms detected something moving too fast to be a solar system object. Initial calculations suggested the object was following a hyperbolic trajectory, the telltale signature of an interstellar visitor passing through our cosmic neighborhood. The significance of this discovery cannot be overstated, as interstellar objects are extraordinarily rare, with astronomers estimating that only one passes within observable range every few years. 3IATLAS immediately became the most important astronomical target of 2025, with observatories worldwide redirecting their instruments to track this cosmic wanderer. The International Astronomical Union worked quickly to assign the official designation, marking it as the third confirmed interstellar object with the 3-1 prefix. Maria Womack, program director for NSF's Astronomy division, called the discovery a once-in-a-generation opportunity to study material from another star system. The object's detection validated new automated survey systems designed to catch these fleeting visitors before they disappear forever into deep space. The discovery story. Late June 2025 began like any other observing period for the ATLAS asteroid survey, a system designed to detect potentially hazardous asteroids approaching Earth. The 4-telescope array across Hawaii and South Africa continuously scans the sky, taking images every few minutes and comparing them to identify moving objects. On June 28, the automated detection algorithms flagged an object with unusual motion characteristics in the constellation Lynx. Larry Deneau and his team initially dismissed it as a processing error, as the object appeared far too large and bright to be a typical asteroid at such distance. Confirmation observations using the Canada-France-Hawaii Telescope and Gemini Observatory revealed that the object was indeed real and moving at extraordinary speed. By July 3, enough observations had accumulated to calculate a precise orbit, confirming that 3IATLAS was following a hyperbolic path characteristic of interstellar objects. The Minor Planet Center in Cambridge, Massachusetts coordinated the global observational campaign, with telescopes from Chile to Australia contributing tracking data. Alan Fitzsimmons from Queen's University Belfast led spectroscopic observations that revealed the object's unusual surface composition, confirming it was unlike any known solar system body and validating its interstellar origin. a stranger in our midst. So, 3I/Atlas really defies every expectation scientists had about interstellar objects thanks to its extraordinary size and mysterious properties. It's moving at about 150,000 miles per hour relative to the Sun, which is, way faster than any natural body born in our solar system could achieve without some kind of external acceleration. Davide Farnokia from NASA's Jet Propulsion Laboratory calculated that 3I/Atlas measures between 6 to 12 miles across, making it potentially 100 times larger than Oumuamua and, honestly, the biggest interstellar visitor ever detected. The object's brightness varies dramatically over a 12-hour period, which suggests either an extremely elongated shape or maybe surface features that reflect light differently as it rotates. Unlike typical asteroids that maintain steady brightness, 3I/Atlas shows magnitude variations of 2.5, indicating a highly irregular structure. The German Aerospace Center noted that the object's albedo, its reflectivity, is unusually high, suggesting a composition that's really different from most solar system bodies. Thermal infrared observations by the Spitzer Space Telescope detected no heat signature, which implies the object is either extremely reflective or made of materials with, pretty unusual thermal properties. But most puzzling of all is the object's trajectory, which shows slight deviations from pure gravitational motion, kind of similar to the mysterious acceleration exhibited by Oumuamua, but honestly on a much larger scale. The predecessors. The story of interstellar object discovery actually began on October 19, 2017, when Robert Warwick spotted Oumuamua using the Pan-STARRS telescope. This cigar-shaped visitor, measuring roughly 400 meters long, showed some pretty strange properties, including unexplained acceleration and an unusually high reflectivity that totally baffled scientists. Abraham Loeb from Harvard University even controversially suggested Oumuamua might be artificial technology from an extraterrestrial civilization, a hypothesis that, really divided the scientific community. Just 2 years later, amateur astronomer Gennady Borisov discovered 2I/Borisov from his observatory in Crimea, providing the second confirmed interstellar visitor. Unlike the mysterious Oumuamua, Comet Borisov behaved exactly as astronomers expected, developing a typical comet tail and showing predictable outgassing as it approached the Sun. Stefano Bagnullo from Queen's University Belfast led studies revealing that Borisov had a composition similar to comets from our own outer solar system, suggesting, similar formation processes across different star systems. The contrast between Oumuamua's anomalies and Borisov's normalcy really established a baseline for what interstellar objects should look like. Now 3I/Atlas represents a third data point, and its unusual characteristics are once again challenging our understanding of what natural interstellar objects can be. The cosmic journey. 3I/Atlas entered our solar system from the direction of the constellation Lynx, following a trajectory that suggests it originated from the Vega star system, which is about 25 light-years away. Orbital dynamics specialist David Farnokia calculated that the object has been traveling through interstellar space for about 5 million years before entering our solar system in early 2025. The visitor's path will take it closest to the Sun in December 2025 at a distance of 0.7 astronomical units, so that's closer than Earth's orbit but not close enough to significantly heat its surface. 3I/Atlas will pass within 50 million kilometers of Mars in November 2025, providing a unique opportunity for spacecraft observations using the Mars Reconnaissance Orbiter and the European Mars Express. After its solar encounter, the object will be gravitationally accelerated by the Sun's gravity, eventually reaching speeds exceeding 200,000 miles per hour as it exits our solar system toward the constellation Pegasus. The entire journey through our solar system will span about 18 months, with the object remaining visible to large telescopes until mid-2026. NASA's trajectory analysis indicates that 3I/Atlas will never return, continuing its lonely journey through the galaxy for millions more years before, maybe, encountering another star system. A scientific gold mine. So, 3I/Atlas, it's honestly a once-in-a-lifetime chance for scientists to examine untouched material from another star system. And, this time we've got modern astronomical tools that just weren't around during earlier interstellar encounters. James Green, who used to lead NASA's Planetary Science Division, actually described this discovery as the most scientifically valuable interstellar object we've ever found. And that's really because of its size, how close it is, and, the advanced technology we can use to study it. The James Webb Space Telescope, for example, has set aside 50 hours just to observe this object, using infrared spectroscopy to hopefully uncover the chemical fingerprints of the star system it came from. And Michelle Bannister, over at the University of Canterbury, is heading up an international team that's using the Atacama Large Millimeter Array to hunt for molecular signatures that might tell us more about where and how this thing formed. Now, unlike Oumuamua, which you probably remember faded out of sight pretty quickly, 3I/Atlas is big enough that we can keep watching it for a much longer time and with several different instruments. Lucy Lim, a planetary scientist at NASA Goddard, pointed out that studying interstellar objects like this is really the only direct way we have to analyze material from other star systems, without, waiting centuries for an interstellar mission to get there. So, by looking at what this object is made of, we might learn whether the way planets form is pretty much the same everywhere, or if it changes a lot from one star system to another. And that could totally reshape our understanding of how exoplanets form and just how likely it is to find habitable worlds orbiting other stars. Unanswered questions. Despite months of intensive observation, 3I/ATLAS continues to puzzle scientists with anomalies that resist conventional explanation. Marco Michelli from the European Space Agency has detected slight non-gravitational acceleration, similar to Oumuamua, but without any visible outgassing or comet-like activity. The object's surface appears completely inert, showing no signs of water vapor, carbon monoxide, or dust emission despite approaching the sun's heating zone. Thermal modeling by Alan Harris suggests the object's interior temperature should be sufficient to sublimate ice, yet no outgassing has been detected by even the most sensitive instruments. The object's unusual brightness variations remain unexplained, with some astronomers proposing it might be tumbling chaotically through space rather than rotating normally. Spectroscopic analysis by Vishnu Reddy from the University of Arizona revealed a surface composition unlike any known asteroid or comet class, showing spectral features that don't match meteorite samples or solar system objects. Most perplexing is the object's perfect preservation. After millions of years in interstellar space, it shows no signs of cosmic ray damage or space weathering that should have altered its surface. These mysteries have led some researchers to question whether 3I/ATLAS formed through natural processes or represents something more exotic than conventional astronomical objects. The alien question. The unusual properties of 3I/ATLAS have reignited debates about the possibility of artificial objects traveling between star systems. Abraham Loeb, who previously proposed that Oumuamua might be extraterrestrial technology, has examined 3I/ATLAS data and noted several characteristics consistent with manufactured rather than natural origins. The object's high reflectivity, unusual shape, and lack of outgassing despite solar heating mirror the properties expected from artificial materials designed for interstellar travel. SETI Institute scientist Seth Shostak acknowledged that while natural explanations should be preferred, the object's anomalies warrant serious consideration of alternative hypotheses. Loeb's analysis suggests that if 3I/ATLAS were a light sail or probe, its large size would allow it to maintain structural integrity during million-year journeys between stars. However, most astronomers favor exotic natural explanations, with Daryl Seligman from the University of Chicago proposing that the object might be composed of unusual materials like solid hydrogen or nitrogen ice that wouldn't outgas detectably. NASA's position remains that extraordinary claims require extraordinary evidence, but the agency has allocated additional observation time to gather more data. The debate highlights how little we understand about the diversity of objects that can form in other star systems and travel through interstellar space. Observing the visitor. 3I/ATLAS has triggered the largest coordinated observational campaign in astronomical history, with over 100 telescopes worldwide contributing data to understand this mysterious visitor. NASA's Hubble Space Telescope provides high-resolution imaging capable of detecting surface features, while the James Webb Space Telescope analyzes infrared signatures that reveal composition and temperature. Ground-based observatories including Keck, Gemini, and the Very Large Telescope conduct continuous monitoring to track brightness variations and search for outgassing signatures. Radio telescopes led by the Green Bank Observatory and Arecibo successor facilities listen for any artificial signals, though none have been detected. Planetary radar systems at Goldstone and Arecibo attempt to map the object's shape and rotation, but its distance pushes the limits of current radar technology. Amateur astronomers worldwide contribute observations using increasingly sophisticated equipment, with citizen science projects analyzing thousands of images for subtle changes. ESA's Gaia spacecraft provides precise astrometry measurements crucial for tracking the object's trajectory and detecting any acceleration anomalies. The Spitzer Space Telescope, despite being retired, was briefly reactivated specifically to observe 3IATLAS using its infrared capabilities. This unprecedented global effort demonstrates how rare interstellar visitors unite the astronomical community in pursuit of understanding our cosmic neighborhood. 3IATLAS continues its journey through our solar system, carrying secrets from another world that may never be fully revealed. Whether it's an exotic natural object or something more extraordinary, this massive visitor has already revolutionized our understanding of what travels between the stars. As we develop better technology to detect and study these cosmic wanderers, each new discovery brings us closer to understanding our place in the galaxy. Subscribe to Stellar Tech for more groundbreaking discoveries that challenge everything we thought we knew about the universe and our cosmic neighborhood.